Hello and welcome. In this video, we're going to look at arithmetic sequences. In particular, we're going to find the common difference. We're going to write out the terms of an arithmetic sequence if we're given the closed or explicit sequence. We're going to find a recursive formula for an arithmetic sequence, and then we're going to use the explicit formula for an arithmetic sequence or closed formula. And so closed and explicit for us will be one and the same. So sometimes I'll say closed. Sometimes I'll say explicit. Now consider a woman who starts a small contracting business. She purchases a used pickup truck for $25,000, which as of today, September of 2022, that must not be a very nice truck because we all know the prices, if you've looked around, are just astronomical. But let's assume she was able to get a screaming deal on a truck for $25,000. After 5 years, she estimates that she will be able to sell the truck for $8,000. Assuming the loss is the same each year, what would be the value at the end of 1, 2, 3, and 4 years? So basically, this is like a linear type of depression in terms of decrease in the value of the truck. So if 5 years it's gone down from 25 to 8,000, that's like saying at year 1 you have 25,000 is your initial amount, and at year 5 you have 8,000. Now remember in our last video that if we were to plot these individual points and connect the lines, which we're not going to because this is a sequence, not a line, but if I were able to, that it would have a linear shape. And so if it has a linear shape, it's like a slope. So in other words, what I'm trying to do is I'm trying to find the common difference per year that's going to get me from 25,000 down to 8,000 in that 5 years. So I have 8,000 is my ending point after 5 years. 25,000 is my beginning point at the beginning or the end of the first year. And then I'm going to have 5 minus 1. So I have negative 17,000 divided by 4. And this is going to tell me how much it is depreciating each year. So 17,000 divided by 4 gives me 4,250. So each year it's going down negative $4,250. So at A sub 1 is 25,000. A sub 2 would be 25,000 minus that 4,250. A sub 3 would be, and this is where I can throw in that recursive, it would be A sub 2 minus that 4,250. And then A sub 4 would be A sub 3 minus that 4,250. And my A sub 5, of course, should end up with the 8,000. So bam, look at that. I threw in some recursive. But you're like, okay, well, how would I write the formula for this? Well, the way I'd write the formula is I'd say A sub 1 is equal to the 25,000. My A sub n would be equal to my A sub n minus 1. And then notice how each time I'm pulling off the 4,250, and so I'd have my previous one and then it'd be minus the 4,250. And I'd only be pulling off the previous one. So look, bam, recursive. Now that's not the ideal way to do it. The ideal way to do this would be the A sub n, if I'm doing an arithmetic sequence, would be the 25,000, which is my starting amount. And then since it's going down, it's going to go down by 4,250. But on that first year, I want it to be 1. So I'm going to write this as n minus 1. Now that allows me to say, well, when I put in 1, so if I put in 1 here, I have 25,000. If I put in 2 here, then it's 25,000 minus the 4,250, which would get me the value at the end of year 1. So bam, here's another way to do it non-recursive. So when we are looking at a arithmetic sequence, the first thing we want to do is figure out what the difference is. It's called a common difference. Now, notice how it is wrote. It is wrote as A sub 1, and then A sub 1 plus the difference, and A sub 2 plus 2 times the difference, then A sub 1 plus 3 times the difference. And that allows me to actually do it recursively as well, sort of, because it is always referring back to A sub 1. So if we know the sequence is arithmetic, do we have to subtract every term from the following term to get the common difference? And the answer is up to you to look that up. Hopefully by the end of this video, you'll be able to answer that. If I'm trying to determine if a sequence is arithmetic, the first thing I always do, by the way, is I always look to see if I have a, just trying to lock my screen here, so give me a moment. So I locked my screen, so now it doesn't rotate. That's one of my crazy things that I don't like my stuff to rotate when I'm trying to move down the slide. Anyways, so I digress. I bird walked, as my students say. If I'm trying to decide if I'm given a sequence, the first thing I'm going to do is the easiest one, easy, and to check to see if it's an arithmetic sequence. So I look to see if I'm going up or down by the same amount or the common difference. Here I'm going up by from 5 to 10 is 5, from 10 to 15 is 5, from 15 to 20 is 20. So I know that this is in true arithmetic sequence and the common difference is 5. And it's a plus 5. So yes, arithmetic, because, so as you know, I'm asking you all for reasons when you take the assessment. I want you to tell me why you know. Yes, this is arithmetic, and here is the reason. Because each term is the same, or each term has the same difference. Each term has the same difference between terms, and it is plus 5. So that plus 5 tells me I'm going up, and the difference is 5. Take a look at my next one. So I have 100 and then 20. So the difference there is 80. And the difference between 20 and 4 is 16. So this is no, not arithmetic. Because the difference between terms is not the same. So if this is on an assessment and I'm asking you to determine the type of sequence, you can say it's not arithmetic. Excuse me, sorry. It's not arithmetic because the difference is not the same. We're going to learn different types of sequences, so you could say it is a geometric because, but this one is definitely not arithmetic. As I take a look at C here, I'm going to ignore the negative because I know it's an alternating. So if I'm ignoring the negative, then I just look to see, well, I'm going to 70 to 75, 80 to 85, 90. I bet the next one would be 95, and it would be a negative 95. So this is alternating. And if you ignore the alternating part, so if you ignore the alternating piece, it is arithmetic because the common difference my spelling and my writing's atrocious, is 5. And it's a plus 5, ignoring the alternating, it's going up by 5. I always say that you should get foreign language for this class because you have to read my handwriting. Plus, you have to read the math that I'm also throwing at you. Okay, so this one, I can just look by inspection. It has that linear shape. Now, remember, if it's presented as ordered pairs, it is not a linear function. So I really can't just say, oh, I'm going to connect the dots and call this a linear function, because it's not a linear function. It is a sequence that satisfies a linear function shape, if I were to be able to connect the dots, but I can't. So because it has the shape of a linear function, it satisfies the shape of a linear function. If I'm allowed to connect the dots, which I'm not, then I have an arithmetic sequence. So this is yes, and this is because the common difference between terms is the same. And in particular, it happens to be plus 2 because I'm going up 2 each time. My input again is 1. That is my domain. My input is 1. My output is -3. Input is 2. Output is -1. Input is 3. Output is 1, and etc. So then how do we come up with the closed or explicit formula? Well, there's a couple of ways to do it. If I'm given the original part and they're telling me what the difference is, then I can just go ahead and continue to subtract off or add that difference to each term. So in my first example, I have the a sub 1, which is -25, and my d is -9. So my next term would be a sub 2, and this is going to be a -25 minus 9, which gives me a -34. My a sub 3 would be the previous term, which is -34, and then subtract off the difference again. And this gives me a -43. And then my last term, a sub 4, would be the previous one, which is -43 minus 9 more, which gives me a -52. Now, the other way I can do this is build the geometric or the arithmetic sequence, but we're not quite there yet. We'll get there. So if I take a look at my next one and I'm asked to add 2/3, my a sub 2 is going to be my previous term, so this is recursive. It'd be 0, and then I'm going to add 2/3. So my second term is 2/3. My a sub 3 would be my previous term, which is 2/3 plus another 2/3, which gives me 4/3. And then my a sub 4 would be my previous term, which is 4/3 plus the new 2/3, which gives me 6/3. So that's just finding the next term. Now, if I wanted to jump to the 10th term, I am not going to write all these out. Instead, what I'm going to do is probably find the explicit or closed formula. So how do we do this? Well, the way that we do this is we figure out what a sub 1 is, and then it's going to be plus, here's the formula, plus n minus 1 times d. Now, I alternate this. I kind of change this up a little bit, and I say, wait a minute, I actually want to write it. I'm gonna combine these, and I'm going to say, if I know that a sub n is equal to a sub 1 plus, and if I distribute the d through, I have that difference times n minus that difference. And what I do in the notes, the handout that I give to you, so when you take this assessment, is I combine these up and I call that a sub naught. So I write this as a sub naught plus d multiplied by n. And it just shortens up a little bit. Where a sub naught is going to be equal to a sub 1 minus my difference. So let's go back and look at how I'd write these formulas, these closed or explicit formulas for up here. Now, the closed or explicit formula for the first one would be a sub n is equal to my a sub 1, which is -25, plus, and if I do the n minus 1 multiplied by my difference, which is -9. So this would be -25 minus 9n plus 9. So my a sub naught, this is where my a sub naught comes from. It comes from these two. I'm going to take the -25 and subtract off d. So in other words, I'm going to subtract off a -9, so that's why it becomes a +9. And so that number becomes a -16 minus 9n. So now I have a nice condensed closed or explicit formula, and I can jump to any term I want. If I want the 10th term, all I have to do is put 10 in for n, and I can tell you what my 10th term is. If we take a look at my second example, my a sub n is equal to my a sub 1, which is 0, plus n minus 1 multiplied by my d, which is 2/3. So my a sub naught, combining up like terms, I'm going to have a -2/3 plus 0, so it's a -2/3 plus 2/3 multiplied by n. And all I did was I distributed this through and combined up like terms, just like here I distributed through and combined of like terms. So here is a nice, concise, closed or explicit formula. Okay. So here we have the a sub 1 and the a sub 7. So in other words, I got to figure out what my difference is. How far did I travel from a sub 1 being 17 and a sub 7 being 31? Now remember how I started it out? It was kind of like finding the slope. Now these are not true slopes, but I can certainly find the difference. And so my first order pair would have been 1 and 17, and my second order pair would have been 7 and negative 31. So my difference is going to be negative 31 minus 17 over the 7 minus 1. So in the numerator, I'm going to get a negative 48, and then in the denominator, I'm going to get 6. So my difference is negative 8. So my a sub n is going to be 17 plus n minus 1 multiplied by negative 8. Now I'm going to just kind of combine this up a little bit and condense this. And so I know this is the same thing as when I distribute the negative 8 through onto both of those two terms. I'm going to get 17 plus 8, which is 25. And then it's going to be minus 8n. If I want the first 4 terms now, I can easily find the first 4 terms. My a sub 1 is already given to me. My a sub 2 is going to be 25 minus 8 multiplied by 2. My a sub 3 is going to be 25 minus 8 multiplied by 3. And my a sub 4 is going to be 25 minus 8 multiplied by 4. And notice I can go right and jump to those terms, and I don't need to find the previous term. It's not a recursive. It's just like, bam, here's your answer. Now, the same thing we're going to do on a sub 13 and 60. So I have the ordered pair. 13 goes in, negative 60 comes out. 33 goes in, negative 160 comes out. So I'm going to find my difference. This is not a slope. This is the difference. So my difference then is going to be a negative 60 minus a negative 60, negative 160 minus negative 60, and then it's going to be 33 minus 13. So in the numerator, I'm going to get a negative 100, and in the denominator, I'm going to get 20. So I have a common difference of negative 5. So my a sub n is going to be, oh, wait, how do I figure out my a sub 1? I don't have my a sub 1. Don't I need my a sub 1? Absolutely do. So how do I find my a sub 1? Well, I know that the difference happens to be a negative 5. So what did I start out with to get negative 60 if I ended up with at a sub 3 at negative 60? Well, the way we're going to do this is like we did here, except for this time I'm going to have an input of 1. I'm trying to find my y value, quote y value, and I have 13 and negative 60. Now, I could have used the 33 and the negative 160. It would have been totally fine, so I have the negative 60. So my a sub 1, actually, let me write this as a sub 1 instead of y. So I'm going to call this a sub 1. So I have negative 60 minus a sub 1 over my 13 minus 1, which needs to equal negative 5. So all I have to do now is solve for a sub 1. And when I solve for a sub 1, it ends up becoming 0. So my closed or explicit formula for this would be a sub n is equal to a sub 1, which is 0, plus n minus 1 multiplied by that negative 5. So my a sub n, my closed formula is positive 5 when I distribute. So positive 5 plus 5, and then it's going to be minus 5n. Now let's look to see if this works for a sub 33. And I put in 33, so I have minus 5 times 33. And 5 times 33 is 165. And 165, a negative 165 plus a positive 5, this does indeed give me a negative 160. So there is my closed or explicit formula right here. And I did that by using my algebra that I learned in Pre-Calc 1. So here's where we talk about being able to use a sub naught instead of a sub 1. It's totally up to you. I will take either one. This is where describing what everything is. A sub naught is the initial term that is not listed. It's like the intercept, right? If we had this as a line, it would have been the y-intercept. The d is the difference, n is the number of terms. So how do we write this as recursive? Well, we kind of talked about this up above, so let's go ahead and do this with a recursive. What am I doing? I want to lock that. Okay. Lock that. Okay. So what we do then is, first of all, determine what the difference is. So our difference between these two terms, this is plus 20, and this is plus 20. To write it as an explicit arithmetic sequence, we know it's going to be a sub 1 is equal to my first term, which is 40, plus n minus 1 times my difference, which is 20. Now we're going to clean this up just a little bit, and so we know this is 20 plus 20n. There it is explicit. As a recursive, the way we write this is a sub 1, we have to give that, which is 40, and then a sub n is going to be the a sub n minus 1 plus just the difference, which is plus 20. So here is the explicit or closed, and here it is plus this has to be a part of it as a recursive. So it's always saying, hey, take your previous one and just add 20. So let's take a look at the next one. So between negative 15 and negative 7, this is not alternating because of the fact that it's negative. They're both negative. They're not. It's clearly not alternating. And to get from negative 15 to negative 7, I added 8. From negative 7 to 1 is adding 8. So my a sub n is going to be negative 15 plus n minus 1 multiplied by my difference of 8. Just kind of combining this up a little bit, I'm going to get negative 23 plus 8n. And there it is in a nice, concise, closed or explicit formula. And then my a sub 1, I'd have to give you my a sub 1 first. My a sub 1 is equal to negative 15. And then my a sub n is equal to a sub n minus 1 plus 8. And here it is in a recursive. Now on the next one, before I could even consider whether or not it is arithmetic or anything else, I have to look to see if it has anything going on with the denominators. Now I go from 5 to 20 to 10. Not arithmetic. I go from 1 to 9 to 7. Not arithmetic. So then maybe I need to have a common denominator. So let's make these a common denominator and say a is equal to, and common denominator is 20. So I have 4 over 20, and then 9 over 20, and then 14 over, there it is. Now you can see that each one is moving up by 5 over 20. So our common difference is 5 over 20. So our a sub n is going to be equal to 4 over 20 plus n minus 1 multiplied by 5 over 20. So then my very first term, if I write this in a more concise manner, my term that's really not there, my initial term that's really not there, would be a negative 1 over 20 plus 5 over 20n. So there it is in a concise manner. As a recursive, I would have a sub 1 is 4 over 20, and a sub n is equal to a sub n minus 1 plus 5 over 20. In other words, plus my difference. So here it is as a recursive. Now, if I want to know the number of terms in a finite sequence, the first thing I'm going to do is build the explicit formula, and then I'm going to set my explicit formula equal to that final number. Then I'm going to solve for n, and that's going to tell me how many terms I have. So I notice that as I'm going from 8 to 1 and 1 to negative 6, I'm going down by 7. So my a sub n is equal to 8 plus n minus 1 multiplied by negative 7. In a more concise manner, this is going to be 15 minus 7n. So there's my closed or explicit formula. Now I set this up to equal that final term, which is 41. Now I'm going to solve for the n, and that's going to tell me how many terms I have. And this works every time you have an arithmetic sequence. So I have a negative 41. I'm going to subtract off 15. Negative 7n is equal to negative 56. That means n is equal to 8. So I have 8 terms. Now, how do I know this? Well, everything I just said, if I had to justify my reason, is after you find the closed formula or explicit, it must equal the final term. Then solve for n to determine the number of terms. And that's perfectly fine for justification. That gives you exactly what you just did, and it explains what you did. So if I want to find a specific term, it's not going to be anything different than what I did. The first thing I'm going to do is I'm going to find a sub n. Then, second thing, plug in the given n. So again, this is my explaining what I'm doing. I found my a sub n, my closed or explicit formula, and then I plugged in the given n. So I want to plug in 12. But before I plug in 12, I have to figure out what my explicit formula is. So I have to figure out what my difference is. So it looks like I'm moving up by 7. So my a sub n is going to be 4 plus n minus 1 multiplied by 7. So my a sub n is going to be equal to negative 3 plus 7n. So a sub 12 is equal to negative 3 plus 7 multiplied by 12, whatever that happens to be. And that's how you're going to do all of these. First, you find your a sub n, and then you just plug in 12 or 17 or 10 or whatever it is that you are looking at. So here's an example. Here's an application. A 5-year-old child receives an allowance of $1 each week. His parents promise him an annual increase of $2 per week. So what I know is this. At year 1, he gets $1. Now my year 1 is a 5-year-old. Year 2, he gets $3, because that's $2 more. Now, this is when he's 5 years old. This is when he's 6. But I'm counting it as my input is 1 and my input is 2, because I'm looking at the domain being the natural numbers or the counting numbers or the positive integers. So then year 3 would be 3 more, so that's 5. So I know that my a sub n is going to be year 1 plus n minus 1 multiplied by my difference, which is 2. So I end up with negative 1 plus 2n. So I know that year 1, which is when he's 5, that he's going to get $1 a week. So the question then is how much is he going to get when he's 16 years old? Well, remember, I'm starting year 1 as being 5. Year 2 is 6. Year 3 is 7. So then what would be the input when he's 16 years old? Well, from 1 to 5, year 1 is 5 years old, so that's a 4-year difference. From 2 to 6, that's a 4-year difference. From 3 to 7, that's a 4-year difference. So I would be putting in 12. So my input, my n, would be 12. So a sub 12 is going to be negative 1 plus 2 times 12. And so his weekly allowance, his or her, I guess it's his weekly allowance, their weekly allowance, is going to be $23. Because I know I'm going to be looking at year 12 is really 16 years old. So, because this is year 7, 7 years old, ... So when he is 12 years old, they are 12 years old, they will have $23 a week in allowance. So that's it for this video. It's a nice short video, 30 minutes, and we'll go over any questions you have in class. Otherwise, you have a great afternoon.